Hello everybody, Ms. Cullen here, and I am going to show you a video on factoring with GCF and trinomials. So what I have up here already has to do with trinomials, okay? So trinomials means we have three terms here. Normally we talk about these in standard form when we are factoring, all right? And we're going to use this fun little game here that Ms. Cullen came up with. We call this the X method. It's fun. Okay, so we're going to talk a little bit more about this. First, I want to review on GCF, and then we'll get a little bit more into the X method. But you will notice that I started to already set those up on some of my piece of paper, and you may do that as well if you'd like to. Okay, so first things first, let's start with a little refresher. All right, if we start with number 1 here. All right, we just have a binomial. That means we have two terms here. So I have a 56a cubed and a negative 8a. And if we remember my lesson on GCF from before, we know that the GCF, we're going to take the greatest common factor and the lowest variable. So here, checking the greatest common factor first, we're going to say, okay, well, 8's my greatest common factor with 8, right? Does 56 divide 8? Yeah, it does. 8 times 7 is 56. Okay, so I can take out an 8 from both of these terms, and I have an a cubed here and an a here, which means I can take out an a. I can't take out more than I have, so I can only take out an a. In parentheses, I will write what I have left. All right, so I have left here 56 divided by 8 is 7. If I took out an a, I still have a squared here. And if I took out an 8a, guess what? I just have minus 1 left here. Everything's gone. Okay, how can we check our work to make sure we did it right? Well, we can distribute it back in, and when we do that, we get 56a cubed minus 8a. So I did it right. This is the factored form. Okay, that's a little refresher on that. You guys should know how to do that by now, though. We're going to dive into talking about trinomials, and I'm going to go through some examples with you there. So the first thing is you always want to look for your GCF, okay? So that's why it's GCF and trinomials. Here, in number 5, my trinomial starts with 1, which means there is no GCF. I can't take out a 7 from 10. I can't take it out from anything, right? There is no GCF. So when there's no GCF, we can jump right into the X method. And the X method says take your A times C. Well, A is going to be 1 most likely. So 1 times C, right? This is A, B, C from this form. AX squared plus BX plus C. So I'm going to take my A times C. 1 times 10. That's 10. That goes up here on the top of my X. And down here is my B. Okay? And what this fun little game says is, what are two numbers that multiply to 10 and that add to 7? Okay, two numbers that multiply to AC and add to B. Okay, so I'm trying to find, okay, what are two numbers that multiply to 10 and add to 7? It's kind of like a puzzle. You have to think about it. Those two numbers are 5 and 2, right? 5 times 2 is 10, and 5 plus 2 is 7. Okay, so I've completed my puzzle. And now how I'm going to write this is in factored form. I'm going to use my variable k, and I have k plus 5 times k plus 2. Okay, that's a form we're going to factor it into. You factor it into a binomial. Okay, remember before when we were taking two binomials and we were multiplying them by each other and we were ending up with trinomials? We're reversing that now, right? Remember when we did this? We did, okay, k times k, that's k squared, plus k times 2, that's 2k, plus 5k, plus 10, and then we simplified these and we got k squared plus 7k plus 10. Look, that's where this came from. Here we are undoing that process and we're saying, okay, well, where did we get this from? Where did this come from? This came from k plus 5 times k plus 2. Okay, so that is the factored form, while the other way is standard form. Okay, so we're going to keep that as our answer. Okay, so I'm actually going to have you try 6, but I do want to help you set it up. You're going to find two numbers that multiply to 63 and add to 16, and write them in the form n plus blank times n plus blank. Okay, now we can do that because the GCF there is 1. Okay, so same thing here. I'm going to help you guys kind of just set these up, make our little X methods here. Okay, we're going to have two things here that multiply to negative 24 and add to negative 2. Okay, so I think you guys should be able to do 6 and number 7, but let's talk about number 9. Why are we talking about number 9, Miss Cullen? Because my A is not 1 here, okay, which means I most likely have a GCF. And if we look at this, I do have a GCF. You should be able to recognize right away, what can I take out of all of these? I can take out a 2 out of all of these, okay? So before you do your X method, right away, you have to take out that GCF. Your A needs to be 1, okay? So I'm going to take out my 2. When I do that, I have x squared minus x minus 6. Not 6. What is 6 divided by 2? 3. Good. Okay? So I took out my 2. That is going to stay in my answer. But now I need to find two things that multiply to negative 3, and add to negative 1, right? There's really a little invisible 1 there. Okay, so yes, I have to deal with the negatives too. Two things that multiply to 3, well, that's only 3 and 1, right? Okay, but I want it to add to negative 1. Okay, so two things that multiply to negative 3 and add to negative 1. Oh no. Can I do that here? Is there anything that, can 3 and 1, can I subtract 1? No, that won't give me, no, that won't give me, right? There's no way to do that. So if that's the case, my X method doesn't work, this is just my simplified version. It's as far as I can go for right now. Okay? It's as far as I can go. All right. Let's come down here. Okay. All right. And we are going to talk about these 3 all down here. Okay? So let's start with number 10. All right, so the first thing I check for is a GCF. Do I have a GCF here? Well, I have a 3 and 18 and 15. And that's when I ask myself, okay, does 18 divide by 3? Does 15 divide by 3? Yes, they both do, which means I have a GCF here of 3. Why can't I take out an X, Miss Cullen? Because there's no X here. Okay, you can only take it out if it's in every term. So 3 is in every term, so I can divide 3 from every term. I'm left with x squared plus 6x plus 5. Okay, once I get here, I'm going to check for my X method and see if my puzzle works. Okay, I'm trying to find two numbers that multiply by 5, or multiply to 5, and add to 6. Okay, well, the only two numbers that multiply to 5 are 5 and 1. Okay, and do they add to 6? 5 plus 1 is 6. 5 times 1 is 5. So now I'm going to write it in the same format, but I got to bring down my 3. Do not forget that GCF. So that's going to come out in front, and I'm going to have x plus 5 times x plus 1. And that is the simplified form. My GCF is out in front, and I have two binomials here. Okay? All right, next one. Do I have a GCF? No, so I can start with my X method. I want to find two things that multiply to 144 and add to 24. Okay, so think about this. When you think about it, you should think, oh, 12 and 12. Okay, so I can write this as x plus 12 times x plus 12. Or we can write this as x plus 12 squared. Right? There are two of them. Okay, either way. Okay, and my last one here. This is very important. This is actually called difference of squares. Okay? And difference of squares says if you have something where you can take the square root of the first term and get a perfect square and take the square root of the second term, in between subtraction or divided by subtraction, then you can use difference of squares. You can take the square root of the first and the square root of the second, and it's x minus x plus. Now, we've seen this in the reverse form, okay? So the square root of x is x, okay, and the square root of 16 is 4. So we can break it up in the form x minus 4, x plus 4. Why? Because this should look familiar. Remember what Ms. Cullen said, that the only time that you're going to take a binomial times binomial and you will not get a trinomial is when you have something that will cancel out. So here we have x squared plus 4x minus 4x minus 16. So these cancel and I'm left with x squared minus 16. Okay, so difference of squares says if you have something like this, you can just break it into this because you know that's where it comes from. Okay, so we'll go over more difference of squares problems, but that should kind of get you started. All right. All the x method ones we already kind of set up together. Okay, so here you need to find two things that multiply to negative 24 and add to negative 2. Okay, when you do that, make sure you first think about, okay, well, what about 12 and 2? No, those won't add to 2. Okay, what are some other ones? 8 and 3, no, I can't get 2 that way. But 6 and 4, I can, right? But be careful, which one is negative? Because they need to multiply to negative 24 adds a negative 2. So it's not 6 minus 4, it's actually negative 6 plus 4 will give me negative 2, and negative 6 times 4 will give me negative 24. So how do we write this? K minus 6 this time times k plus 4. Okay, all right. Please try these problems. And then on the next page, you should be doing the same thing. The only thing here that's a little bit different is solving. Okay, so we're actually going to talk more about this in the next chapter, but these are already in factored form for you. So we're actually going to use the zero products property here. And the zero products property says that if you have something in factored form, you can set each of these equal to 0 to solve. So d minus 7 equals 0 and d plus 4/3 equals 0. Add 7, d equals 7, and subtract 4/3, d equals negative 4/3. Okay? You can try these problems. All you're doing is setting each equal to 0 and solving. All right? Down here, you are factoring out the greatest common factor, and then you're factoring. Here, okay, you have a trinomial, and here you have a trinomial. First, look for your GCF. Your GCF here is a v. You have a v in every term. So when we take that out, we'll have v squared minus 5v plus 9. And we want to find two things that multiply to 9 and add to negative 5, if possible. 3 and 3? No. 9 and 1? No. So guess what? This is it. Okay? Here might look a little bit different. Here I can take out a 6q squared. Because I have, or not a 6, I'm sorry. 15 isn't divided by 6. A 3q squared. Because all of these, the greatest common factor is 3. They all divide by 3. And they all have q's in them. Okay? So when I do that, then I have 2q to the third minus 7q squared minus 5. Okay? And the AC method does not work for something like this, so that's also done for. Okay, I hope this helped you guys. Have a great day.